Welcome to Unit 1, Lesson 14. We are going to be doing 3 equations with 3 variables in them, okay? In the past, we've done 2 equations with 2 variables, and now we're doing 3 equations with 3 variables. Now, we're going to use the same sort of process. In order to do this, we are going to make our 3 equations turn into 2 equations with 2 variables and go from there, okay? So it's a little bit kind of more of the same, if you will, just a little extra twist in the beginning to make it so. But before we get started, okay, this is where my thought process is with how I do these things, okay? And I'm hoping this is how yours is as well. So I'm going to write this down. If you want to write it down as well, you can. And then I'm going to erase it, and then we're going to work on this problem. So the first thing is, okay, and we just said this, we need to get 2 equations with 2 variables in it. That is going to help us, okay? So we're going to eliminate one of the variables, all right? And how do we eliminate a variable? Well, we need to eliminate one variable, okay? And we need the same coefficients. Now, coefficients are the numbers in front of the variables. Okay, that's 2, 3, 3, okay? Don't forget, these are ones. If they're not written, they're ones. We need the same coefficient in front of the same variable, all right? And last but not least, we are going to eventually combine equations so we can get rid of a variable. And when we do that, we're either going to add 2 equations together completely, or we are going to subtract 2 equations from each other. Now, the million-dollar question is, how do we know if we add or if we subtract? The S right here. If the signs are the same, then we subtract. All right? If the signs are not the same, then we do not subtract. We would add. Now, what I'm about to write in black, I don't want you to write down. I just want to show you how this makes sense, this step 3 here. If I have a positive 5 and I have a positive 5, okay? If I add those, now notice the signs are the same, right? I should be subtracting them. If I add those, I'm going to get 10. It's not going to go away. If I subtract them, it goes away. The signs are the same. Same thing with negatives, -5 and -5. If I subtract them, if we subtract a negative, that's like one of those super positives, it still goes to 0. Now, likewise, if the signs are not the same, then we do not subtract, we add. That goes to 0. Okay, -5. If I add them, they cancel. That goes to 0. So this is the basis behind whether we add or subtract. Okay, if the signs are the same, like they were here, and they were here, remember, we subtracted a negative, right? Then you subtract, and it goes bye-bye. All right, so write this stuff down if you need to pause it. Write this 1, 2, and 3 step. You do not have to write this right here that I'm erasing. And we're going to start our problem. All right, so I'm going to read this problem. I'm going to read what we have here. They give us 3 equations. They say 1x plus 1y minus 1z equals 4. 1x minus 2y plus 3z equals -6. And 2x plus 3y plus z equals 7. So now we got to select which variable I want to get rid of. Because again, we want to make 2 equations with 2 variables. So I'm going to take, love the highlighter, the top equation and the middle equation, and I'm going to combine them, okay? All right, I'm going to combine them to make 1 equation. And if I look, which variable has the same number in front of the x? There's a 1 and a 1. and they're both positive. So remember, if the signs are the same, you subtract. So I'm going to take those two equations, and I'm going to subtract them, okay? I'm going to rewrite them first. I got x plus y minus z equals 4, and x minus 2y plus 3z equals negative 6. Okay, now I'm going to subtract them, so please, please, please be careful. When I subtract, I'm going to subtract every term in here, which means I'm really just distributing my negative sign so I can subtract. Okay, so if I distribute my negative sign, this becomes negative, this becomes positive because I'm flipping all these signs. This becomes negative, and the 6 becomes positive. So now I can combine my like terms. My x's go bye-bye. Boom, that's exactly what I wanted. I now have 1y plus 2y, 3y. Minus 1z and minus 3z is minus 4z equals 4 plus 6 is 10. Okay, that's one equation with two variables. Now I need a second equation with two variables, and then we can go ahead and solve this. All right, now, what two equations can I pick? I can pick any two equations as long as they are not the same two equations, meaning I cannot pick the first and second one again. I can pick the first one and the third one. Okay, I can pick the first one and the third one. I can pick the second one and the third one. I just cannot pick the first two again because I already did. Now, on top of that, what I want to do is I want to get rid of my x as well, no matter which two I pick. So here's what I'm going to do. I'm going to pick the second one. Screw that. Let's pick the first one and the third one. How about that? Let's make it easy. All right. The first one and the third one. I got x plus y minus z equals 4. And I've got 2x plus 3y plus z equals 7. Now, you can look at that and say, hey, I see something, Visca. I see it loud and clear. The z is both ones in front of it. There's a negative one and a positive one. We don't want to get rid of the z. We want to get rid of the x. How come? Because, yep, that's nice. Damn. We want to get rid of the x because look here, I have a y and a z. When I'm all done with this equation, I still want to have a y and a z. I want to get rid of the x as well. So we have ourselves a problem. I see 2x here, but I don't see 2x here. I've got to multiply everything here by 2. So I can get 2x when I'm all said and done. Everything, including the answer, okay? So I'm now going to rewrite the equations, but I'm going to distribute my 2 to the first one. So I have 2x plus 2y minus 2z equals, so now 8. And then I'm just going to rewrite my second one as it is because there's already 2x there. 2x plus 3y plus z equals 7. Now, my 2's are both positive, which means I want to subtract them. I'm subtracting the entire second equation, which means I got to distribute that negative sign. I'm going to change all the signs in my second equation. I'm going to flip them because I'm going to negate every single one of them. That goes bye-bye, negative. This becomes negative. This becomes negative. And this becomes negative. I flip every single sign. Now I can combine them. My positive 2 and negative 2x, gone. 2y minus 3y would be negative 1y. Minus 2z and minus 1z is minus 3z equals 8 minus 7 is 1. I now have two equations, and both equations green. Both equations have a y and a z in them. So now it's just the same point as before. I've got two equations with two variables. Now it becomes slightly more manageable. These problems, and I tell this to my class, they take time. It's like doing 2 or 3 problems in one. Whenever you see a 3-variable system of 3 equations, sit down and the first thing in your head is, this is going to take time. Let's just spend the time on it and get it right from the get-go. All right? So let's combine my two equations, shall we? 3y minus 4z equals 10. Negative y minus 3z equals 1. Neither the y variable or the z variable has the same number in front of it. I'm going to choose to get rid of the y, which means I have a 3y here. I would like a 3 in front of this y. So I'm going to multiply everything in here by 3, and I'm going to rewrite my equations. Okay, so the first one, I'm just going to rewrite it. I have 3y minus 4z equals 10. The second one, I now have to distribute that 3. Negative 3y minus 9z equals 3. Now the signs in front of my 3's, they are different. They are not the same, so I am not subtracting, I'm adding. So I don't have to distribute my negative sign or anything, okay? Let's see what we got. 3y's go boom, by. Negative 4z and negative 9z give me negative 13z equals 10 plus 3 is 13. Oh, nice. Z should be negative 1. Okay, if I divide both sides by negative 13, z equals negative 1. That's one of my 3 variables. I now need my y variable and my x variable. So let's go back and start plugging in numbers. I cannot plug z into any one of these equations because I still don't have an x or a y. But I do have two equations, one right here and one right here, that have a z and a y. I know what z is, so if I plug a z into any of those equations, I can solve for y. I'm going to choose this equation right here. Negative y minus 3 times my z equals 1. Z is negative 1. Okay, so negative y plus 3 equals 1. Okay, subtract 3 from both sides. Negative y equals negative 2. And if I divide by negative 1, y equals 2. I now have 2 of my 3 equations. Now, at this point, I can plug my y and my z value into any one of these equations up here. I can pick the top one, the middle one, or the bottom one. I'm going to pick the top one because it seems like the easiest. Okay? You could pick the middle one or the bottom one, and you would still get the same x value if you plug in our y and our z. All right? So x plus y minus z equals 4. X plus y minus z equals 4. That was one of our original equations that had 3 variables. X, which is what I'm solving for, plus y, which is 2, minus z, which is -1, equals 4. So x plus 2, when I subtract a negative, it becomes a super positive, +1. I can combine these two. I get x plus 3 equals 4. Therefore, x equals 1. How did I get that? If you subtract 3 from both sides, x equals 1. So I have 3 answers. Okay? Well, I have one answer with 3 variables, I should say. X, Y, and Z. It's 1, 2, and -1. Wow. What did I say? I said it's going to be a lot of work. Just get your mind wrapped around it that it's going to be a lot of work. And I'm going to review this, okay? I'm going to review this, and I'm going to make a couple of points. The next one I do, I'm going to go slightly quicker. The one after that, I'll go quicker and quicker, okay? This first one, I just want to make sure you were following. I was given 3 equations, okay? 1, 2, 3. The first thing I had to do was I had to get 2 equations with 2 variables. So I picked the first 2 here, okay? Then I had to subtract them, and I got this bad boy. Good. Then I picked the first one and the second one, and I got this bad boy. Okay, those are my 2 equations with 2 variables. And then after that, I had to get rid of one of the variables, and I did, and I ended up with Z. I plugged Z into one of my equations with 2 variables to find Y, and I did. Then I took my Z and my Y, and I had to find my X by plugging it into one of the original equations. Now, the thing that stinks for a teacher to grade problems like these is the following. You could have picked, I mean, there are multiple ways to do this, meaning you could have picked, instead of how I picked the first 2, you could have picked this middle one and this second one to get rid of a variable, okay? I could have picked the first one and the third one here, and I could have said, hey, the Z is the same thing. I could have gotten rid of the Z first and just had my X and Y. There are multiple ways to do this. But here's the one thing that's common between every single way you could have picked to do this. It is really easy to make a simple math mistake when you're doing this much basic algebra. This is basic algebra. This is easy stuff. It is just a lot of easy stuff. I tell my classes, if I take a sheet of paper and I cut it in half with a pair of scissors, that's easy. But if I have 500 pieces of paper and I need to pick them up individually and cut them all in half with a pair of scissors, that's a lot of work. It's a lot of easy work, but it's a lot of work. Okay? These problems are a lot of work, but they're a lot of easy work. Don't let your mind try and move faster so you make a simple math mistake. Like instead of adding 2 and 3, you subtract 2 and 3. Or instead of multiplying 3 times 4, you add 3 times 4 because you're going fast. Take your time, get it right. There are no bonus points for finishing first. Okay? Let's take a look at another problem. Yep, and again, this board is off. There you go. What do we have here for number 2? Solve for A, B, and C. 5A plus 7B minus 3C equals -18. -4A minus B plus 8C equals -4. And 6A plus 3B minus 2C equals 0. I don't see any coefficient or any of the big numbers that are the same in front of the variables. Like there are no A's that are the same. I hope you can see this. This doesn't seem like oh my God, is this thing off again? The A's, no numbers are the same. The B's, no numbers are the same. The C's, no numbers are the same. All right? So we're going to have to multiply in order to make numbers the same. So this is what my mind is telling me. And again, you can do it differently. If you want to pause this and do this problem out, you might get some numbers that are slightly bigger, but you can use a calculator. Okay? Do it. And then if you get rid of a different variable than I do in the beginning, that's fine. Stick with it. See if you get the same answer. Because as long as you get the same answer, you've solved it correctly. All right? I, in my mind, am going to get rid of the B. How come? Because I can multiply this B times anything. I can multiply it by a 7 here to match the B above. And I can multiply it by a 3 to match my B below. It's only multiplying one thing, okay? Sometimes we need to multiply our two equations by two different numbers so that we get the same value in front of the variable. It sucks, but hey, what are you going to do? It's just one extra step in multiplying. So let me begin. Let's take the first two equations, okay? I'm going to say 5a plus 7b minus 3c equals negative 18. If I'm getting rid of my b value, I need to multiply everything in here by 7, okay? That's negative 28a. And let's be careful here, okay? Minus 7b plus 56c equals negative 28. Now, my b values have the same number in front of them. Are the signs the same? No. So do I subtract? No. I add. Whew. This is where you got to be careful. It's another place. Okay, I should get negative 23a. These go bye-bye. Plus 53c equals negative 46. Yeah, those are some ugly numbers. But everything should work out as long as we're doing our math correct. All right. Let's take, now I could take the top equation and the bottom equation, or the middle equation and the bottom, which is what I'm going to do. And I will do this. Okay. I will rewrite the bottom, 6a plus 3b minus 2c equals 0. Now, in order for me to get rid of my b's, I want to be a 3b here. So I'm going to multiply this whole thing by 3 now. Minus 12a minus 3b plus 24c equals negative 12. Now look at my b values. The number in front, are the signs the same? No. So do I subtract? No. I add. I get negative 6a. Gone. Plus 22c equals negative 12. I now have two equations with two variables, an a and a c. And I'm going to combine those to get rid of one of those variables and make life easy. This bad boy goes right here. So I have 6a, that's minus 6a. See how easy it is to make a mistake. Plus 22c equals negative 12. Oh my goodness gracious. I need to get rid of an A or a C. Wow. Here's what I'm going to do. I'm going to get rid of A. And how am I going to get rid of A? I need to multiply both of these by some big numbers, okay? I'm going to take my 6, put it here. I'm going to take my 23 and put it here, and I need to distribute these. Good thing we have a calculator. And I'm going to turn this thing on. I'm going to go over here, okay? 6 times 23. That's 138. So when I distribute here, I get negative 138A. And when I distribute here, I also get negative 138A. Okay. 6 times 53. Oh, it's positive. That's going to be 18. Carry the 1. 3, 18C equals, oh my God, 36. Carry the 3. That's 24. 27, negative 276. I'm going to check those. 6 times 53, 318. 6 times 46, 276. We're good. All right. Now we need to multiply our bottom equations. 23 times 22 and 23 times 12. 23 times 22, 506. Holy smokes. Plus 506 C equals 23 times negative 12, negative 276. So let's see. Those are big numbers, but something's going to happen here that makes life really, really easy. Okay? Our signs are the same. So I have to subtract this whole thing, which means I'm going to change the signs of everything in here. This will turn to positive, so it goes bye-bye. This will turn to negative. Holy potatoes. So 506 minus 318. 188. 188C, and this will go from minus to plus, equals 0. If I multiply any number times something and get 0, that something has to be 0. I now have a value for C. So let me tell you this. If this were a finals question, I don't think you would ever get numbers that high. Okay? Maybe I'm wrong. But I think this is a lot harder than a finals question. So if you could do this, if you did this another way, and for your C value, you got 0, and you're waiting to see what I come up with for A and B, you did good. You did real good. So let's take a look and see if we can find another variable. Now that we know C is 0, okay, I can use either this equation here in blue before I multiply the 6, or this equation here, okay, which I wrote in black before I multiplied the 23. I'm going to use the second equation. I'm going to use this. And I'm going to say negative 6A plus 22C equals negative 12. Why did I pick that? Because once I throw in 0 for C, this goes bye-bye. It just becomes 0. So I just got to divide by negative 6. Could I have picked the other equation? A should equal 2. Could I have picked my other equation up here? Yes. And guess what you would have gotten for A? You would have still gotten 2. Okay? Now, I have an A and I have a C. I need to figure out what my B is. So I can pick any of these first three original equations. The one that looks easiest to me is the bottom one because it's equal to 0. And I've got 2 and 3 and 6, which are relatively small numbers. So I have got, okay, 6a plus 3b minus 2c equals 0. I'm using this equation. I have an a, that's 2. I'm solving for b, and I have a c, which is 0, should equal 0. So I've got 12 plus 3b minus 0 equals 0. This goes bye-bye. I'm going to subtract 12 from both sides. And I've got 3b equals negative 12. And if I divide both sides by 3, b equals negative 4. Woo! So I have an a, a b, and a c now. A is 2, b is negative 4, c is 0. Holy pancakes. Oh, my Lanta. Holy smokes. That's a lot of work. That is harder than any question you'll get in the final. And it's good that you're doing the harder problems because if you get one in the final, it should seem easier. Okay? I'm going to stop here because, man, my brain, well, my brain's ready for more math. But yours, I can look at you. I can see you through your camera. Yeah, I'm creepy like that. You look tired. Have a break. Get some water. Sit down. Don't start playing video games if your mind is mush right now. It's only going to get worse. Sit down, you know, and watch a show, do something, drink some water, and then come back and watch the part 2 to this video later if you're behind, or if you just need to get, you know, a little bit of a brush up on your 3 equations with 3 variables. I'll see you for part 2 later.